So this video is about electromagnetic phenomena, which is part of IGCSE physics and O-level physics. EDXL physics is also included, so the students who are from EDXL can also watch. So the question number 1, an extremely ultraviolet nuclear reaction is taking place at the center of sun. It is the reaction that enables the sun to emit a very large amount of energy and extremely large number of charged particles. So, A part is asking to name the type of nuclear reaction taking place in the sun. So, nuclear reaction are of two types, fission and the second one is fusion, okay? And particularly in sun we have nuclear fusion. In fusion process, basically nuclei are combined and fusion occurs. Nuclei can be any isotopes, so they basically combine, fusion occurs, and as a result of this fusion some more nuclei are produced. Along with this, nucleons, which are basically charged particles, and they're also mentioned in the questions, nucleons are produced and a large amount of energy. This is also mentioned in the question, so you can see from here. So this is a fission reaction, and in sun nuclear fission takes place, as a result of which we get heat energy, charged particles are released, and obviously nucleons are produced. Okay, next question. Many of the charged particles produced by the sun are emitted from its surface at high speed and they travel into the space. So part 1 is explain why these particles constitute an electric current. And we clearly know about the fact that current is movement of charge, right? So current is movement of charge, and in this case we have charged particles that are moving, so we can say it's a current, right? So movement of charged particles. In this case, the charged particles we have is nucleons, so I can mention this as well. So movement of charged particles is referred as current. Okay, so next question is asking that state the equation that relates the electric current to the electric charge that is flowing, and also define any other term in the equation. So basically their very popular equation that relates current and charges is I equals to Q over T, and obviously this is the definition of current, which says that it is number of charges flowing in a unit time, or per second we can say it. And here there is an extra term which is T, so let me mention that as well. T is time in seconds. Okay, so coming to the next part. In the next part, the question says some of the particles emitted by the sun travel straight towards the earth until they enter the earth's magnetic field, and because they constitute a current they'll experience a force and got deflected. So basically when there is something carrying a current and it is in magnetic field, so it will obviously experience some force. Okay, let us discuss few facts first before doing this question. The first fact is Earth has a magnetic field around it. So Earth behaves like a magnet. It has north pole, it has south pole. An electric field of lines emerges from north pole and then it enters the south pole. So this pole is south, this is north. An electric field of line goes in this direction, and they leave north pole and they enter south pole. So this is basically the diagram of magnetic field of Earth. Let me make it more precise for you. Okay, so the second very important fact, that is when we have these three quantities in combination, force, B is magnetic field obviously, and I is current. So firstly, whenever we have a magnetic field and there is a conductor, current carrying conductor in a magnetic field, it will always experience a force. Okay, so when there is a current and there is a magnetic field, the force is generated. So always, if a current carrying conductor is placed in a magnetic field, it will experience a force. And if we have a force and a magnetic field in combination like this, for example, there is a magnetic field and there is a force which is applied to some closed loop or closed conductor, so it will always produce a current. Always there will be EMF generated in that conductor. So magnetic field and current in combination produce a force, and force and magnetic field in a combination produce a current, and they're always mutually perpendicular to each other. C, force is perpendicular to magnetic field is perpendicular to current. Everything is within 90 degree to each other. So our question is asking that describe the relationship between direction of force that the charged particles are experiencing and the direction of current. So we can see from this Fleming's right hand rule diagram that force and current are in 90 degree to each other. So I'll write perpendicular to each other. The next question is direction of magnetic field and the direction of force. So again, clearly the magnetic field and the force are again 90 degree to each other, so they are again perpendicular to each other. So conclusion is, whenever there is a charged particle that is moving in a magnetic field, so basically the current and magnetic field are in combination, so it will always experience a force which would be 90 degree to the magnetic field and the current as well.